Hello Internet, Zach here, and welcome back to Collecting the Elements. I know it's been more than 2 months now since I've had an official video with a new element up, and I'm sorry about that. After I got my video about lithium up, it was time for apartment inspections, and I had to make everything related to chemistry disappear for 2.5 weeks while we waited for the inspector who didn't show up, and then finally showed up, and then there were contractors, and it was just a messy situation. Why did I have to make all the chemistry stuff disappear? Because there's a bit of a stigma against amateur chemistry in the US, and if you're some random dude and you have improvised chemistry equipment made of glow sticks and Gatorade bottles lying around, people can get the wrong idea, and that was a risk I wasn't willing to take. So anyway, after all that blew over, I didn't have the budget to get any new reagents to get new elements out of, so I was trying to figure out what I could do with what I have on hand without having to spend any money. So I spent about 1.5 months fighting with iron. Element 26, a hard silvery gray metal. Actually, my sample looks black. That's pretty normal, actually. So it's a hard silvery metal. Sometimes it's a hard black metal. Other times, that's how iron is. And by the way, its salts reek. I am, at this point, so tired of iron salts. I will be glad if I never see them again, but I'm going to have to deal with iron salts again in the future, because iron's an impurity in some of the things from which I can extract the lanthanoids. Oh well, it is what it is. So in this episode, I'm going to electrorefine iron. That's not the way I originally wanted to do a video about iron for you. Originally, I wanted to do the classic thermite reaction. Unfortunately, crowded neighborhood, what better way to piss off your neighbors and get in a lot of trouble than lighting off thermite in the backyard. So, you know, you're going to have to settle for electrochemistry again. So here goes. Alright, so I'm going to attempt to grow iron crystals. I'm going to start with steel wool as a source of metallic iron. Steel wool being an iron alloy. It's mostly iron with a few % carbon as an impurity. I'm going to put that in here. And I'm going to use hydrochloric acid to dissolve the steel wool. And that'll make a solution of iron chloride, which I'm then going to attempt to electrolyze to grow iron crystals. So let's let that sit in there a while and dissolve. This has been going on for about half an hour, and I want to see if I can speed this up just a little bit. So to help oxidize the iron, I'm going to try adding just a little bit of hydrogen peroxide. Any iron that's already in solution as Fe2+ ions will be quickly oxidized to Fe3+, and those will be even better at attacking the metallic iron than the hydrochloric acid alone already is. Notice the instant color change. Now the metallic iron should start pretty quickly reducing the Fe3 plus ions, which are this yellow-brown color, back to the much paler green Fe2 plus ions. And in the process that should really eat up the steel wool. Okay, so after fighting with the iron chloride solution for quite a while, I've finally gotten a small-scale test to produce some half-decent iron crystals. Focus. So it's time to scale this up so I can make a nice element sample out of them. Now, one of the problems I'm running into, though, is that my iron anodes are falling apart. I've been using steel wire, steel wool, and the electrodes just fall apart. So I'm going to use a steel tuna can as an electrode, and because it's coated with some plasticky stuff, to keep the cans from rusting to pieces, I'm going to have to remove that. So I have some really coarse 80 grit sandpaper, and I'm just going to take that coating off with this. Okay, I entirely screwed up the footage of making the electrolysis solution here. So I'm going to make a much smaller batch just to show you how I did it. Because, well, it's good to know, right? So I started with some baking soda, sodium bicarbonate, and put it into the electrolysis container. I then added some water to dissolve the baking soda. Stir up the baking soda to dissolve it. Then I took the iron chloride solution, added that to the baking soda with much fizzing. And that causes an orange-brown precipitate of iron carbonates and hydroxides to form. Now every time I add more of the iron chloride solution to this, the pH gets a little lower and it gets more acidic. At a certain point, come on. At a certain point, the iron carbonate will redissolve, and that's the point where I know that I've gotten the pH where it needs to be. There it is. The solution suddenly turns a transparent green, and that's the point when the pH is right. So I'm just going to add that to this electrolysis bath here. And show you that some iron has already grown on my graphite electrode. Check this out. Graphite's not magnetic, but the iron coating sure is. So I'm going to put that back in here to grow some more iron. Alright, this has been electrolyzing for about 6 hours. And they're hard to see on camera, but some strange looking iron crystals. When I grew these, I had the voltage turned up to 6 volts from the original 4.5 to see if I could make them grow faster. And when I was down at 4.5 volts, this was growing more of a just flat sheet of iron. So I'm going to turn the voltage back down to 4.5 volts, and I'm going to put this back in and see if that makes this shiny and silver colored again. Take a look at what this reaction did to the tuna can. Alright, I had to dismantle the experiment in a hurry because the landlord's contractor showed up with no warning. And I had to make everything chemistry related disappear again. So I'm back, and I'm going to detach the iron from this graphite cathode, or at least I'm going to try to, and collect it all in this coffee filter to let it dry out, and eventually I'm going to wash it with some vinegar to remove any rust that's formed on it. I'm kind of out of the frame here. This is tricky. I apologize. It's a little tricky to stay in frame right now. Is that still iron? Oh yeah. That's still more iron to take off. Okay, do I have it now? Right, there's a piece here. Okay, there's a little attraction to the magnet left, but not a whole lot. So it looks like I have most of the iron off of here. A couple of pieces that are stuck really well. But they're not super pretty. Into the camera, this doesn't look like much at all. But yeah, that's iron. Sticks well to a magnet, just like metallic iron should. So, time to wash it, clean it up, and bottle it. Okay, so here's the iron I've managed to make, and I'm going to put it into this jar here, and I'm going to pour in some distilled vinegar. It's because the iron's been kind of wet, and that causes it to rust. So I'm going to shake up the iron in the vinegar to try to clean it up a little bit. It's not exactly silvery and shiny yet, but let's give it a couple of minutes in there and see if it looks better. Alright, so to speed things up, I added some water and I added a few drops of hydrochloric acid to try to just eat the rust off as quickly as I could. So I've done the best I could with that. Okay, so I've poured the liquid off, and now I'm going to put all of my iron here into this filter. Well, all the big pieces anyway. Come on. Get in there. There we go. Okay. Now I'm going to give this a quick rinse. With clean water. Wash all the acids off of the iron. Actually, just to make sure all the acids are neutralized, I'm going to give it a little baking soda too. Any excess baking soda will dissolve in the rinse water. I just want to make sure that the acids are out of here, because the acids will degrade the iron. I'm going to give this a second rinse, this time with some isopropyl alcohol. That should wash most of the water off of the iron. It'll also make the iron dry a lot faster. Okay. Now, when you're out of paper towels and you don't have money for more, it'll just have to do to dry the iron out on some toilet paper. Okay, not quite dry yet, but I transferred the iron back to the jar. And I'm actually going to give it a quick rinse in pure acetone, because that'll dissolve the water off, and it'll also evaporate off of the iron particles a lot faster. Okay, the iron has been rinsed with acetone and is almost completely dry now. Trouble is, yeah, some of the pieces still look a little rusty. The cleaning step wasn't perfect. And now, of course, the part we've all been waiting for. A tube full of iron. Chunky bits of iron. And there it is. Iron. Well, I hope you enjoyed that, and hopefully I'm going to be able to get back into making element videos regularly again. I do still have some issues getting my housing squared away after the end of this month, so I'm going to be moving the table again to a new home. Anyway, if you liked this, hit the like button. If you enjoyed it and know someone else who would, hit the share button. Hit subscribe if you want to see more, and don't be afraid to leave comments. See you next time.